Today we're going to look at paired difference tests for dependent samples. Let's look at some examples of dependent samples. Remember, dependent samples are samples that are related to one another. There's a relationship between the two. The first example of dependent samples is before and after tests. We can take a weight loss program and check the person's weight before the program and the person's weight after the program. This is an example of dependent samples because we're talking about the same individual. They're being tested before and they're being tested after. We also have matched pair design, and this is used to control the effects of other variables. For example, if I want to compare shocks, I can install one brand of each on each car and use the same type of driving, mileage, etc. And after a certain amount of miles, let's say 20,000 miles, we're going to test the shocks for strength and compare the differences in strength of each shock. We need to look at some assumptions before we start the problem. The samples have to be dependent samples. Sample data are matched pairs. If the number of paired observation is less than 30, we have to check the differences for normality. The mean difference of a population is mu sub d, and that's equal to the mean of the first group minus the mean of the second group. D is equal to a particular observed difference from a pair. D bar is the mean difference of the paired observations of the sample. So of all of the differences between each of the pairs, we're going to take the average. That's what D bar represents. And D bar is calculated by taking the summation, or the total of all of the differences, and dividing it by the number of pairs of observations, and n is our sample size. Here is our test statistic. It is t equals d bar over the standard deviation of the difference divided by the square root of the sample size. Here the degrees of freedom is still n minus 1, where the standard deviation of the difference is calculated by the square root of the summation of the differences squared minus the summation of the differences quantity squared over the number of pairs divided by the sample size minus 1. Now we don't need to use any of these formulas because we're going to use StatCrunch for every single problem from now on. If we want to calculate the confidence interval, we take the mean difference and then we add or subtract our margin of error to find the confidence interval. Note, if the degrees of freedom is greater than 1,000, we will use z instead of t because t will approach z for very large degrees of freedom. But then again, we're going to use StatCrunch, so we don't need to worry about looking at z or t. So let's look at example 1. The following data represents the cost of a one-night stay in the Hampton Inn hotels and the La Quinta Inn hotels for a random sample of 10 cities. Test the claim that the Hampton Inn hotels are priced differently than the La Quinta Inn hotels at the alpha equals 0.05 level of significance. Also construct a 95% confidence interval for the mean difference in price between the two hotels. I want to test the claim that the Hampton Inn hotels are priced differently than the La Quinta Inn hotels at alpha equals 0.05 level of significance. So before we start, I need to let the reader know which one's group 1. In this case, let's let group 1 be the Hampton Inn hotel because that came first. And group 2, we'll let that be the La Quinta hotel. Then we'll start our claim. The claim is that they're priced differently. When I see the phrase differently, I know the symbol is not equals. So let's say mu1 is not equal to mu2. The complement to this is mu1 is equal to mu2. Now we can start step 1. In step 1, we're going to look at the null hypothesis and the alternative hypothesis. The null hypothesis is always the one with the equal sign, so mu1 is equal to mu2. In the alternative hypothesis, it's mu1 not equal to mu2. Now there are some notational differences. In the textbook, you'll see they'll refer to the null hypothesis as the mean difference is equal to 0. And for the alternative hypothesis, they'll refer to it as the mean difference is not equal to 0. But just be aware that the notation means the same thing. In step 2, we're going to state alpha. Alpha is equal to 0.05, and that is given here in the problem. In this question, enter the data for the first hotel and enter the data for the second hotel. Select the not equal symbol. That's our alternative hypothesis. I also want to construct a 95% confidence interval, so let's enter 0.95 for the confidence interval and calculate. Our test statistic is 7.37. Our p-value is really small. It's 0.0004. For the lower limit, I want to round it to the nearest cent, so let's say $38.40. And the upper limit is $72.40. Our test statistic is equal to 7.37. Our t-statistic is 7.37. In step 4, our p-value was less than 0.0001. Now we can start step 5, our conclusion. I always ask, is the p-value less than alpha? Is 0.0001 less than 0.05? Yes, it is. So now we can complete part 5. Step 5, since the p-value is less than alpha, we do reject the null hypothesis. There is enough evidence to conclude, and remember our conclusion is always in terms of HA. Recall HA was mu1 was not equal to mu2. So there is enough evidence to conclude the hotels are priced differently. Since the p-value is less than alpha, we do reject the null hypothesis. There is enough evidence to conclude the hotels are priced differently. Now let's construct a 95% confidence interval for the mean difference. From StatCrunch, we have the lower limit is 38.40 and the upper limit is 72.40. Now we're rounding these values to 2 decimal places because we are talking about money. Now the next question that I need to ask myself is there a 0 in the interval? Is there a 0 in the interval? Since both of these numbers are positive, we know there is no 0 in the interval. There is no 0 in the interval. That implies there is a difference. Since both of these numbers are positive, that implies that one of the hotels is priced more expensively than the other. Recall group 1 was the Hampton Inn Hotel, and group 2 was the La Quinta Inn Hotel. Since there is a difference, we're going to write we are 95% confident that the Hampton Hotel is more expensive by between $38.40 and $72.40. We are 95% confident that the Hampton Hotel is more expensive by between $38.40 and $72.40.